This is section 5.3, exercise something, 64. And what they'd like us to do is verify that f has an inverse, then use the function f and the given number a to find f inverse of a. It says hint, see example 5. So, okay, in this one, we have f of x is x cubed plus 2x minus 1. And they say, well, verify that f of x is 1 to 1. Well, yeah, algebraically, that's a little bit difficult, except actually I can do a couple things. So I know it's a cubic, and so verify. Oops, verify. Try that again. Verify 1 to 1. Okay, so that we know it does have an inverse. Well, if f prime of x is always greater than 0 or always less than 0, then in that case, then I know the function is either always increasing or always decreasing, and so it would need to be 1 to 1. So that's what I'll do. I'm going to take f prime of x, and that's 3x squared plus 2, and that is indeed always greater than 0. So this function is strictly increasing everywhere, and therefore it can't double back on itself, right? It's going up. It cannot do something like that, and so I know it's 1 to 1, okay, and I got that from the derivative. Okay, so I know it's 1 to 1, but now, let's see, we're told a is equal to 2, or in other words, we know f of x is equal to 2. But I don't know what f inverse of 2 is. Okay, so, and again, you run into that problem of, it's not obvious to me that I can solve that really easily with a cubic. And so I would resort to using technology. And so I set that up ahead of time. And there we have it. And so I put in f of x is x cubed plus 2x minus 1. So that's our red curve there. And then I said y equals 2. And there's the intersection. And so I see that's at 1, 2. I was thinking it was at 2, 2, but there's 2. Yeah, it's at 1, 2. And so if I come back here, then what I see is that f of 1 is equal to 2. And I can verify that by putting a 1 in there, and I get 1 plus 2 minus 1. So yes, indeed, f of 1 is 2. And so that means that f inverse of 2 is equal to 1. And so if I want my derivative of f inverse, so I'm going to let g of x equal f inverse of x. And so now what I want is g prime of 2. And what we know is that's just 1 over f prime of g of 2. And so that's 1 over f prime of 1. And f prime of 1, well, I go back up here, and that was 3x squared plus 2, so that's 5, and so I get 1/5. And so I guess that's what they want from exercise 64. Now, again, though, given that I've got that information, just like I did with example 5, you could go further and I could say, hey, what's the tangent line? To f inverse of x at x equals 2. And so what this says is it should be y equals my derivative, so 1/5 times x minus my x value 2 plus g of 2. I don't see it here. I'll have to go back and find. Oh, wait, it was 1. But g of 2. And so that's 1/5 x minus 2 plus 1. And so what the heck is that? That's x over 5 minus 2/5 plus 5/5. So I guess that's plus 3/5. Okay, so just let's check this out. I could be, getting myself into hot water here. So we had, I believe, y equals x over 5, so divided by 5, and then plus 3/5, I think, 3 divided by 5, and we get that tangent line now to the inverse function. Well, the interesting thing here is, for one, notice it is going through 2, 1, so that's good. But now if I want to see the inverse function, sorry about that, my pen got close. What I can do in Desmos to do the inverse function is, you see I defined f of x there that way. So then if I just put in, I guess my pen gets close and it jumps, we'll talk about it and I'll get back to it. So you can just type in f of x. So let's try to zoom in here. Whoops, quit that. Oh, is that as far as it'll zoom in? Oh, I tell you, I'm putting my pen up there, so that's not the issue. There we go. Okay, so here's 2, 1. It certainly appears I got the tangent line. So, and again, this light blue line is the inverse function. And notice how it is the mirror image of across y equal x. So let's, well, I'll tell you, sometimes technology is not your best friend. So there are the two functions, and if you look at the y equal x line, so I could just put in an x here, and there's the y equal x line. You see they are mirror images across the y equal x line, and so you can get a nice plot of the inverse function that way. And now I can't do a lot with it in that form, but at least I don't think I can. I don't know. Let's, here, I'll go in here and I'll get rid of the x, and what happens if I say f prime of y? F prime. So I've never done this before. I have no idea what'll happen. It did not like it. Okay, let's try putting an x in front of that. X equals. So x equals. Oh, wow. Isn't that exciting? That is very exciting. So there is the derivative function. Now, you kind of have to turn it. There we go. Let's see. Okay. There we go. That might do it for you, or it's upside down or something like that. But so I turn this thing, so I believe you will see it as a parabola opening down. It really should be a parabola opening up, but hey, don't wreck a good story with facts. And so by kind of turning things sideways, you could get an idea of what the function should look like. But yeah, so you can kind of do some calculation with it, and it says what's f prime at 2. According to this, oh well, yeah, that's not so good. It looks to me like drawing, if you turn it upside, or not upside down, you flip it sideways, it looks like it would be saying the derivative is 0, and the derivative was 1/5. So yeah, I haven't played with this, but obviously it can do some calculations. It's just what the heck those calculations mean is another question. So we'll get that out of there and put our tangent line back that we did so nicely. Okay, so there's our tangent line, and so not only can we get the derivative, but we have all the pieces, since we had to know the x value for f inverse of what? 2, and we had to know its output, 1. In that way, we know we have an xy coordinate pair for the function, and then we have its derivative of 1/5. So if we have its x and y, and then its slope, we can make the tangent line. All right, so that was exercise 64.